Okay, just to quickly recap what we talked about in the previous video. We have these four different scenarios here. In the first scenario, the value of the function is equal to the value of the limit. So I've added some y values in here. And in the first one, we would say that the limit as x approaches c of f of x equals 2, because the value of the function is approaching 2 both from the left and the right as we get closer and closer to c as an x value. In the second diagram, we say the limit, the value of the function does not exist when x is equal to c. However, the limit exists there because the function appears to be heading for 1 both from the left and from the right as we approach c. So we would say the limit as x approaches c of f of x is equal to 1 in that case. In the third example, as we approach x equals c from the left, we seem to be going for y is equal to 1, but as we approach c from the right, the function seems to be heading for y is equal to 4. Since the left-sided limit and the right-sided limit do not agree and don't equal each other, so in that case we say that the limit does not exist. So we would write the limit as x approaches c of f of x does not exist, or DNE. The fourth example, here we have the function has a value when x is equal to c, and that value is 3. And the function has a limit when x is equal to c, and that limit is -2. But those two don't have to agree with each other in order for the limit to exist. So we would write the limit as x approaches c of f of x is -2 in that case. Now I'm going to go on to talk about another special case when for a limit as x approaches c. And that is a case where at x equals c you have a vertical asymptote. Okay, so in uh, example number 5, or in diagram number 5, here we have a point at x equals 0. We can see that we have a vertical asymptote at that point. And whenever you have a vertical asymptote, the limit does not exist. So we'll write a few things here. Now, so we would write the limit as x approaches 0 of f of x does not exist. Um, some books may, since from both the left and the right we appear to be heading for positive infinity, some books may say that the limit as x approaches 0 of f of x is equal to positive infinity. But the limit technically doesn't exist at that point. Now I would reserve using positive and negative infinity for one-sided limits, so I would prefer to say that the limit as x approaches 0 of f of x doesn't exist. However, we could write that the limit as x approaches 0 from the left of f of x is positive infinity. Or we could say that the limit as x approaches 0 from the right of f of x is positive infinity. So when we talk about vertical asymptotes, I would use a one-sided limit to describe the behavior of the function as x approaches some value from either the left or the right. Then once again in example 6, we have another function where it also has a vertical asymptote when x is equal to 0, but as we approach from the left it goes to negative infinity. As we approach from the right it goes to positive infinity. So I would write in this case that the limit as x approaches 0 of f of x does not exist. However, the limit as x approaches 0 from the left of f of x is negative infinity, and the limit as x approaches 0 from the right of f of x is positive infinity. So these are the different cases as x approaches some constant value. We call it c, or in the latter cases it happened to be when x is equal to 0. Now, when there are vertical asymptotes, we can use a one-sided limit to describe the behavior of the function or the direction of the function as we approach from the left or from the right at that point. Alright, so in the next video we'll go on to looking at limits as x approaches infinity, which we also refer to as horizontal asymptotes.